So thank you for reminding me. Yeah, actually I forgot to record. Okay. So the next section is organizing quantitative data. So till now we discussed about qualitative data, how to organize the qualitative data. So now we'll learn how to organize quantitative data. So to organize quantitative data, so similar to the qualitative data, we can use different type of representation. We can use bar chart, sorry, we can use histogram, or we can use also tabular representation. So we can use both tabular and graphical representation. So here we have an example, number of TV sets in each of 50 randomly selected households. So here we have the number of TV sets in each of 50 randomly selected households. So we have 50 households. That's been, we collected data from 50 households, and this is the corresponding numbers. So now the question is, what is the variable here? Can anyone tell me what is the variable here? Households or TV sets?
TV sets.
Yes, the variable is TV sets, right? And we collected it from 50 households. That's mean we have 50 responses. So now the question is it qualitative data or quantitative data? The answer is very simple, right? Quantitative data, because this section is about quantitative data, right? Because the variable takes numerical values. So that's why this is quantitative data. Okay, so now the question is it continuous or discrete? Anyone? What do you think? This is continuous or discrete? Yes, this is discrete. I got so many responses, so this is discrete. So because the possible values are discrete values, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are discrete values, the possible values. So that's why this is discrete variable. So now we'll discuss how to represent or how to organize this discrete data. So we can use frequency and relative frequency distribution using single value grouping for the number of TV sets. So when you will be constructing the frequency or relative frequency table, either you can group the data as a, because in this case, actually we do not have any distinct values to write down. So for qualitative data, we have distinct responses and corresponding frequencies. But here we also have, distinct responses and corresponding frequencies. But sometimes if the distinct responses are, the number of distinct responses are very large, in that case, it is very time consuming and it is not easy to list all the distinct responses and their corresponding frequencies. So in that case, we group the data in a limit. So here we used a single value grouping. So that's when we group the data with a single value. So how many distinct values we have here? We have 0, we had 1, we have 2, we have 3, we have 4, we have 5, and we have also 6. We do not have any other values. So if you look at the table, we have only 7 distinct responses, 0, 1, 2, 3, 4, 5, 6. But if you have more than 7, maybe if you have 50 distinct responses, so it is very time consuming to list all the 50 responses and their corresponding frequencies. So in that case, we use some other grouping, which is called limit grouping or cut point grouping. So we'll discuss about it later. So in this case, since we have only 7 distinct responses, so we can easily list all 7 responses and their corresponding frequencies. So the responses are 0, 1, 2, 3, 4, 5, 6, and their corresponding frequencies are, for 0, it is 1. For 1, we have 16 times, 2, we have 14 times, 3, we have 12 times, and 4, we have 3 times, 5, we have 2 times, and 6 we have 2 times. And total number of observation is 50. So here, this is the total number of observation, 50. So to calculate the relative frequency, you have to divide each frequency by the total number of frequency. So that's mean the first one is 1 divided by 50. So this one is 1 by 50. Then the second one is 16 over 50 and 14 over 50 and so on. So if you add them together, then the total will be 1. If the total is not 1, that means you did some mistake. So you have to recheck, and you have to check, and you have to make correction if the total is not 1. So the total will be always 1, the relative frequency. So this is the relative frequency distribution for the quantitative data, and this is for discrete data because our variable is discrete. So this is another example, days to maturity for 40 short-term investments. So we collected data for 40 short-term investments, and here the responses or the variable is days to maturity. So that's mean the number of days is the variable here, and the number of days varies from investment to investment. So here we have 40 responses, and we have distinct values. So what is the minimum value here? So the minimum value is here, this is 55, yeah, this is 38. So minimum is, I think, 36. Yeah, 36 is the minimum. And maximum is, we have 98, we have also 99. So I think maximum is 99 because all are 3 digits, sorry, 2 digits number. So maximum is 99 and minimum is 36. Okay, so here we have so many distinct values. So in that case, it will not be a good idea to group them as a single value. Instead of grouping as a single value, you can group them as a limit. So limit means, since the minimum is 36, so we can start from 30, or you can also start from 35 because the minimum is 36, but you have to make sure that the limit includes all the numbers. The lower limit to the minimum to maximum, it includes all the numbers. Since the maximum is 99 and the minimum is 36, so we have to group the data so that we include 36 and 39 as well. So the first group is 30 to 39, and second group is 40 to 49. You can also use other different grouping. For example, you can use 35 to 44, then 45 to 54. This also includes the minimum value, right? Because minimum is 36. So 35 to 44 also includes the minimum value, and so on. But 30 to 39, 40 to 49, this is very easy. If you do the grouping in this way, so you can easily do the grouping. So here, this is the days to maturity. So how will we do the grouping? So first, you need to find the minimum number and maximum number. Then you have to consider some groups so that the groups include maximum and minimum. If it includes maximum and minimum, that's when it will include all other numbers. Okay, so our first group is 30 to 39, then 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, then 90 to 99. So this is called limit grouping. So for the quantitative data, you can use limit grouping, but for the continuous data, we cannot use limit grouping. We have to do some other grouping. Yeah, I will discuss this later. Okay. So 30 to 39, how many numbers we have between 30 to 39? Now you have to count how many numbers. So the easy way is if you use the tally mark. So the first one is 70. So the 70 is from 70 to 79. The 70 is here. So you will use just one tally mark for 70 here. Then you will look at the second number. Second number is 64. So 64 is 60 to 69. So you will use a tally mark here. Okay, and so on. So after doing the tally mark, we found that in the first group, we have three numbers. So that's when the frequency is 3. And in the second group, we have one number, the frequency is 1, then 8, 10, 7, 7, then 4. And total is 40. Then we'll calculate so till now we have the frequency distribution or frequency table, but we need to construct the relative frequency table. The last column will be then relative frequency. So that's been 3 divided by 40, 1 divided by 40, 8 divided by 40, 10 divided by 40, and so on. And the total is 1. Do you have any question about this one? Is it clear? Do you have any question about limit grouping? So is it clear when we will use limit grouping and when we can use single value grouping? Okay, thank you. Okay, so here are the related terms in limit grouping. So lower class limit. So what is the lower class limit? Lower class limit is the smallest value that could go in a class. So each group is called a class. So this is the first class, this is second class, this is third class, and this is fourth class, this is fifth, this is sixth, this is seventh. So now the lower limit class. So what does it mean by lower limit? Lower limit means the minimum number that can go to that group. So in this class, the minimum number can go to this class is 30, right? So if we have 30, we will list this number here, right? Because 30 is from 30 to 39. So that's when this is the lower limit of this class. So this is the lower limit of this class, the smallest number that could go in a class. Then upper class limit is the largest value that could go in a class. So what is the upper limit of this class? So the largest value that can go in this class is 39. So that's mean the upper limit is 39. Then next term is class width. So the class width is the difference between the lower limit of a class and the lower limit of the next higher class. So that's mean the lower limit of this class and the lower limit of the next higher class. The next higher class is this one. The lower limit for this one is 30 and this one is 40. So that's when the class width is 40 minus 30. That's when the class width is 10. And you can also consider any two classes. Maybe you can consider this two. The lower limit is 80 and the lower limit for this one is 90. So 90 minus 80 is 10. So this is the width of this class. So here we have equal width for each class, but sometimes you can also have unequal width of classes. Then the class mark, the average of the two class limits of a class. So we have lower class limit and the upper class limit. So the class mark is the actually midpoint of the class. So that's been the average value of the limits of a class. So if you take the average of lower limit and upper limit, that is the class mark. Okay, so now we have another example, table 2.8, which is weight in pounds of 37 males aged from 18 to 24 years. So what is the variable here? Age or weight? So what is the variable here? Anyone? What is our variable in this example? Yes, the weight is the variable, right? Because the response is related to weight, not the age. So we have the weights of 37 males. So that's mean here the variable is weight. So now the question is it continuous or discrete? What do you think? It is continuous or discrete? This is continuous because it can take fractional value. Okay, so forget about this example, this data. For same example, for if we consider weight of 5 persons, so suppose consider weight of 5 person, and we found that weight is 129 pound, 218 pound, 142 pound, 132 pound, and 173 pound. So this is the weight of 5%. So in this case, our variable is also weight. So now the question is, in this case, is the weight continuous or discrete variable? What do you think? Okay, so how many of you think this is discrete variable? Instead of considering this 37%, if I consider just 5%, and if their corresponding weights are 129, 218, 142, 132, sorry, 132 and 173. Okay, so how many of you think this is continuous, and how many of you think this is discrete? Okay, so if you think this is discrete, then write yes, otherwise write no. Okay, yes for discrete, no for continuous. Yes, I got so many no responses. Yeah, still it is continuous, because the types of the variable it depends on the possible values of that variable, not the observed value. So this is actually the observed value, right? This is the collected value. So the collected value could be distinct, but the types of the nature of the variable depends on the possible values, right? There is possibility that it can take fractional values, right? It can take any values. It can take 129.5, 129.3, 129.2, 129.9, right? So it has possibility that it can take any values between two numbers, right? The smallest and the largest number. So it can take any values. So the weight can take any values between two numbers. So that's why this is called continuous. Even though our responses are distinct, 129, 218, 142, 132, 173, still it is continuous. It is not discrete. Is it clear? Yeah. Okay. So now what type of grouping we should do in this case? Should we do single value grouping or limit grouping? What do you think? Yes, limit grouping. Because we have so many distinct values. So even most of the values are distinct. So single value grouping actually doesn't work in this case. So we need to use limit grouping. So what type of limit grouping we should use in this case? So let's first find the smallest value and the largest value. So what is the smallest value here? Can anyone tell me what is the smallest one in the data? What is the smallest number here? Okay, 129.2. Okay, I'm taking this one, 129.2. What is the maximum number? Well, I say 188, 278 also. And is it 278.8? What is the largest number here? Yeah, 278.8, right? 278.8. Okay, so now if I do grouping like this, you said we can use limit grouping. Yeah, I also agree with you. We can use limit. We have to use limit grouping, because till now we know single value grouping and limit grouping. So single value grouping will not work in this case. So we'll go for limit grouping. So now if we do the limit grouping like this, it's started from 129. So we can start from 120. So 120 to 129, then 130 to 139, then 140 to 149, and so on. So do you see any problem in this type of grouping? Do you see any problem in this type of grouping? Anyone? So what is the problem if we do this type of grouping? It takes a while to write out. Not really. We can write out. Yeah, it takes time. Yeah, you're true, but still we can write out. Yeah, then I got another. It doesn't include decimals. Yeah, too many groups. Too many groups is okay. We can use maybe 120 to 139. Then we'll have less number of groups. But the main problem is, yeah, it doesn't include the decimals, right? We have 129.2. So where will go this number? It is not from 120 to 129, right? It is not from 130 to 139. So this group is not taking this number. Even this group is not taking this number. So where should this number go? This number is in between 129 and 130. So that's mean we cannot use for continuous data. Actually, we do not use the limit grouping that we used for discrete data. So we'll use limit grouping, but it is kind of different limit grouping, which is called cut point grouping. Okay, so frequency and relative frequency distribution using cut point grouping. So that's when we'll use this type of group, 122 under 140. Or sometimes we also write, we do not write under, we just write 120 to 140, then 140 to 160, then 160 to 180, then 180 to 200, and so on. Okay, so there is a problem because we have 140 here and we have also 140 here. Now the problem is, if we have a number in our data 140, then in which group we should include that number? In that case, you can include either in this group or this group, but you have to be consistent with each number. For example, if you include 140 in this group, then you have to include 160 in this group, 180 in this, 180 in this group. But if you include 140 in the second group, that's mean you are considering the lower limit, right? Then 160 also should go in this group, not in this group, because here 140 is lower limit. And so you included 140 here. So if you have 160, you have to include here. That's when we consider the lower limit. So either you consider the lower limit or upper limit to include the numbers. Okay, or actually this is the safest one, 122 under 140. So that's mean if you have 140, you have to include 140 here because 140 is not under 140, right? So there is no confusion if you use this type of limit point, grouping. This is called cut point grouping. Okay, so this is already 12:21. So I think I should stop now. And I